One thing that you'll definitely need to be able to do for calculus is to evaluate piecewise defined functions properly. So it should be pretty straightforward, and you should have done this in the past. But if you're asked to evaluate a piecewise defined function, the first thing that you need to do is you just need to look at which portion of the domain the given value you're trying to find is in, and then just evaluate the corresponding part of the function. So if I'm looking for f of 0, I look over here at my restrictions on the different pieces of my piecewise function, say that 0 is less than or equal to 2. So when I'm evaluating f of 0, I need to plug it into the top portion of this, which means I'm going to do 0 squared minus 3, which is negative 3. If I'm looking for f of 2, once again, I just need to look at which piece of the domain that falls into. And so if I'm looking at f of 2, 2 is less than or equal to 2. So I'll again use the top piece of this. So I'll do 2 squared minus 3, which of course is 4 minus 3, or just 1. And if I'm looking for f of 3, that falls into the portion where x is greater than 2. And so I'll just plug it into the bottom piece of that, which means f of 3 should be 3 times the square root of 3 minus 1, or 3 times the square root of 2. We'll do the same thing here for each of these different values we're looking to evaluate. Here we've got a piecewise defined function that's defined with 3 different pieces. So when we look for f of 0, we should be able to see that 0 falls between negative 2 and 4. And so we'll just use that piece of it. We'll do 0 squared minus 3 times 0, which is, of course, just 0. So f of 0 is 0. If we're looking at the next one, f of 5, 5 is greater than 4. So we'll use 2x minus 3. So we'll do 2 times 5 minus 3, giving us 10 minus 3, or 7. When we do negative 3, the next one, f of negative 3 is less than negative 2. So we'll do negative 5 times negative 3 minus 1, which would be 15 minus 1, or 14. When we do 4, we have to look at the piece that includes 4. So here, that's this piece when x is less than or equal to 4. So we'll plug 4 into x squared minus 3x. So 4 squared minus 3 times 4, or 16 minus 12, which is just 4. And for the last one, when we're looking here at f of negative 2, well, we have negative 2 here, and we have negative 2 here. So we should look for the one that includes negative 2. But if we note, neither of the inequalities involving the negative 2 have an or equal to. So in this case, our function is undefined at negative 2. So we'll say that f of negative 2 does not exist. And that's how you evaluate piecewise defined functions. Pretty straightforward.